Hello, in today's video, I'll be solving questions on partition coefficients under A-level Equilibria. The first question is from May-June 2020, paper 4-2, question 5. A. Define the term partition coefficient, KPC. It is the ratio of the concentration of a solute in organic layer to the concentration of the solute in aqueous layer. It is also defined as the ratio of the concentration of a solute between two solvents. B. The partition coefficient, KPC, of benzoic acid between octane 1 ore and water is 79.4. I. A solution of 0.400 grams of benzoic acid in 25.0 centimeter cube octane 1 ore is shaken with 125 centimeter cube of water. Calculate the mass of benzoic acid extracted into the water layer. In this question, 0.4 grams of benzoic acid, which is the solute, is first dissolved in 25 centimeter cube of octane 1 ore, which is the organic solvent. 125 centimeter cube of water, which is the aqueous layer, is then added to the resulting mixture and shaken together. It means that some of the mass of the benzoic acid that was already in the 25 centimeter cube of octane 1 ore will now partition between the octane 1 ore and the water. It means some of the mass will now move into the water layer. Since we don't know the mass of the benzoic acid that has moved into the water, which is the aqueous layer, we can say that let the mass of benzoic acid in the aqueous layer be X. This means that the mass of the benzoic acid left in the organic layer is 0.4 minus X. We can find X by using the formula KPC is equal to the concentration of benzoic acid in the organic layer divided by the concentration of the benzoic acid in the aqueous layer. Concentration of the benzoic acid in the organic layer is equal to mass over volume, and which is equal to the mass in the organic layer or left in the organic layer is 0.4 minus X divided by the volume of the organic layer, which is 25. And the concentration of the benzoic acid in the aqueous layer is also equal to mass over volume, and which is equal to X over 125. Going back to our KPC equation, the KPC has been given as 79.4, and this is equal to the concentration of benzoic acid in the organic layer, which is 0.4 minus X over 25 divided by the concentration of the benzoic acid in the aqueous layer, which is X over 125. So this is divided by X over 125. So 79.4 is equal to 0.4 minus X divided by 25 times 125 over X. And this gives us 79.4 times 25 times X is equal to 125 times 0.4 minus X. We get 1985X is equal to 50 minus 125X. We group like terms to get 1985X plus 125X, which is equal to 50, and so we get 2110X equals 50, and so our X is 0.0237 grams. We got that by dividing both sides of the equation with 2110. KPC of benzophenone C6H5 CO66H5 between octane 1 ore and water is different from the value of KPC of benzoic acid given in BI. Explain why. When you look at the structure of benzophenone, you can see that benzophenone is more non-polar than the structure of benzoic acid. And you can see that the octane 1 ore, which is the organic solvent, most parts of it is non-polar. So it means that benzophenone is going to dissolve more in octane 1 ore than benzoic acid. So therefore, the KPC value calculated in II will be higher than the value calculated in BI. So we can say that benzophenone is more nonpolar than benzoic acid. So it dissolves more in octane 1 ore than water. Hence, the KPC value will be higher than the KPC value calculated in BI. The next question is from October-November 2021, paper 4-2. Question 2. Ethoxyethane C2H5O C2H5 can dissolve both in water and octane 1 ore. The expression and numerical value for the partition coefficient of ethoxyethane between water and octane 1 ore are given. Water and octane 1 ore are immiscible. KPC is equal to concentration of C2H5O C2H5 in octane 1 ore divided by the concentration of ethoxyethane in water. And the KPC value at 20 degrees Celsius is 6.760. A. In an experiment, octane 1 ore at 25 degrees Celsius is added to a solution of ethoxyethane in water at 20 degrees Celsius. The mixture is analyzed immediately and a value of KPC is calculated. The calculation is performed correctly. The value calculated is 5.625. Explain why the value calculated is less than 6.760. When you want to calculate KPC value, after mixing your solutes and your two solvents together, you have to allow the mixture to settle for some time and allow equilibrium to be established before you can analyze the mixture and calculate your KPC value. But in this case, the mixture was analyzed immediately. That means equilibrium was not established. And also for the KPC value to be less than the actual KPC value, it means that the ethoxyethane dissolved more in water than in octane 1 ore at the time this value was calculated. So we can say that equilibrium was not established and the concentration of ethoxyethane was higher in water than the octane 1 ore. And so it was the reason why the value was less than the actual KPC value at 20 degrees Celsius. B. A second experiment was performed and the value of KPC is found to be 6.760. The concentration of ethoxyethane in octane 1 ore layer is 7.62 grams per decimeter cube. I. Calculate the concentration in grams per decimeter cube of ethoxyethane in the aqueous layer. So we know that KPC is equal to concentration of ethoxyethane in organic layer divided by the concentration of the ethoxyethane in the aqueous layer. The KPC value was given as 6.760 and the concentration of the ethoxyethane in the organic layer, which is octane 1 ore, is 7.62. So we can represent the concentration of the ethoxyethane in the aqueous layer with X, since we don't know that yet. It means that X, which is the concentration of the ethoxyethane in the aqueous layer, is equal to 7.62 divided by 6.760, and that gives us 1.13 grams per decimeter cube. 100 centimeter cube of the octane 1 ore layer is taken and shaken with 100 centimeter cube of water. calculate the maximum amount in mole of ethane that can be extracted into the water. So in this question, 100 centimeter cube of the octa-1 ore layer from B was shaken with 100 centimeter cube of water. From B, we were told that the mass concentration of the ethane in the octa-1 ore layer is 7.62 grams per decimeter cube. This basically means that the mass, which is 7.62 grams, was dissolved in 1 decimeter cube of the octa-1 ore layer. And so we can also write this as 7.62 grams over 1000 centimeter cube, because 1 decimeter cube is the same as 1000 centimeter cube. Out of this mixture, we were told that 100 centimeter cube was taken from it and shaken with 100 centimeter cube of water. So we need to calculate the mass of the ethane in the 100 centimeter cube of the octa-1 ore layer. So if 7.62 grams is equal to 1000 centimeter cube, then what will 100 centimeter cube give us? From here, we can see that the mass of the ethane in the 100 centimeter cube of the organic layer is equal to 0.762 grams. So 0.762 grams of the ethane was in 100 centimeter cube of the octa-1 ore, which is the organic layer. Later on, 100 centimeter cube of water was added to this mixture and shaken together. It means that some of this mass would have now left from the organic layer and dissolve in the aqueous layer. So we are able to find the mass that would now dissolve in the aqueous layer, which is the water. And since we don't know the mass of the ethane that would dissolve in the aqueous layer, we can say that let that mass be X. So if the mass dissolves in the aqueous layer, then it means that the mass that will be left in the organic layer will be 0.762 grams minus X. Now we know that Kpc is equal to the concentration of the solute, which is the ethane in the organic layer, divided by the concentration of the solute ethane in the aqueous layer. Now we know the mass and volume of each layer, so it means that we can calculate the concentration of ethane in both layers. The Kpc value given is 6.760, and which is equal to the concentration of ethane in the organic layer, and so that will be the mass of the ethane in the organic layer, which is 0.762 minus X divided by the volume of the organic layer, which is 100 centimeter cube, divided by the concentration of ethane in the aqueous layer, and that is the mass of ethane in the aqueous layer over the volume of the aqueous layer. The mass in the aqueous layer is X grams over the volume, which is 100 centimeter cube. So it means that 6.760 is equal to 0.762 minus X divided by 100 times 100 over X. So we can cancel the 100 on top and below. So it means that we get 6.76 times X and is equal to 0.760 minus X. So if we move this X across the equal to sign so that you can group like terms, we get 6.76x plus X. which is equal to 0.762. And so here we get 7.76x is equal to 0.762. If we divide through with 7.76, we get our x, which is the mass of the ethoxy ethane in the aqueous layer, as 0.0982 grams. But now, since we know the mass of the ethoxy ethane in the aqueous layer, we can use the molar mass of the ethoxy ethane and calculate amount of the ethoxy ethane. The molar mass of the ethoxy ethane can be calculated using the atomic masses of the atoms in the ethoxy ethane, and this can be found on the periodic table. So we have our ethoxy ethane, which is C2H5O C2H5. The molar mass is equal to 74 grams per mole if you do your calculation well. So we know that amount is equal to mass over molar mass. And so our mass is 0.0982 grams divided by the molar mass, which is 74 grams per mole. So the amount is 0.00133 mole. Thank you for watching. See you again in the next tutorial. Please subscribe to this channel.